Okay, now let's get started with our notes. 164, segments in a circle is 10.6, last section or nearly. The objective is I will find segment lengths in a circle. So the first one is when two chords intersect inside a circle. I'm just going to write here that they form equal products, which means that I'm going to say there's two products that are equal in this, and I have to figure out what they are. Remember that the point where they intercept, I'm going to just label that V for vertex. This is the vertex where the two lines intersect. And then there's two lines that intersect, and one of them is AO, and one of them is EI. Okay, so I'm going to say lines AO and EI, or they could be segments. Now I'm going to say the product that I'm going to remember is Vavo Vive. Okay, so that's our product, that's our circle product, and we're going to just remember that. In this example, I have to remember how to do this. So there's my vertex, and I have AO is one of them. It doesn't matter how you do this, but AO is one of them, and EI is the other. So now when I write Vavo Vive, I just plug it in. So VA is here, that's 8 times VO. VO is X. And that equals VI, which is 6, times VE, which is 4. We might just make sure that that looks right in our diagram. This looks like it's the shortest segment, and the other one is 4 and 6. So that looks pretty reasonable. Let's try this next one. So start by labeling the diagram. Here's the center. That's the vertex where they intercept. And then we have AO and EI. So don't forget, AO and EI are segments that intersect. So AO, I'm going to label it one way. This will be AO. And EI the other way, EI the other way. It doesn't matter which way I do it, but one of them's AO and the other one's EI. So here's my formula. So let's just plug it in. VA is X, VO is 3X, VI is 6, and VE is 8. So simplify this, X times 3X happens to be 3X squared because there's X times X there, and this one is 48. So then we have to just remember to divide by 3 before we square root. We're going to divide by 3. We have X squared equals 16. Now we take the square root. We get X equals 4. Plus or minus 4, but we're not going to consider the negative. So that would be our answer. If I wanted to figure out what this is, so this would be 4, and this 3X would be 3 times 4 is 12, and that would be my two segments going along this way. All right, let's take a look at the next one. When two segments intercept outside a circle. Okay, remember the segments are going to, well, the lines are going to be AO, that's one line, and EI is the other line. I make sure that those intercept. I'm going to label this AO, okay, because that has to be one of them, and this one EI, that's the other one. And then where the intercept is V, that's the vertex. So when two segments intersect outside a circle, they form equal products. Those equal products in this case are Vavo Vive. This is our formula we're going to use. Let's use it in these two examples right here. In the first case, I have this, and I'm just going to make sure I label this V, and this would be AO. Now, it doesn't really matter how you label AO as long as that's one line segment that intercepts V, and EI over here, EI. So now I'm going to go ahead and set up my equation. Plugging things in, VA. It looks like VA goes from the vertex all the way over here, and that's 9 given in the problem. VO is from here to here, which is X. And then down here I have VI, which is 4. And VE goes all the way to there, so that's 12 times 12. So now we solve this. Okay, now the next one, let's go ahead and set that up. Okay, so now let's plug stuff in. VA is 5. VO, okay, now this one I noticed that it's all the way across, so I have to add these two things. That's X plus 5. So I'm going to write X plus 5 in parentheses. Now I'm going to plug in the VI and the VE. So VI is all the way across again, so that is 6 plus 4. And that is 10. VE is 4. So here we have it, and now I have to solve this. In this case, I must distribute first. So I have 5x plus 25 equals 10 times 4 is 40. Continuing. Okay, now we're going to do when a secant and a tangent intersect outside of a circle, and we're going to just assume this is a tangent in this case. So let's go ahead and label this diagram. When I do this, I'm going to say, well, this is the vertex V. This is A. Now, O is out there, and I don't really care where it is, so I'm just going to leave it, and this is E and I. So now I'm going to say that they form equal products. And those products are formed by these segments. And the first one is VA times VA. Okay, now I'm going to just say that's our formula, va vive. And let's go ahead and use that a couple of times. So in this first case, there's two ways to really know that we have a tangent. Well, three ways. We could be told that. Or in the diagram, if we see a line that just intersects a circle in one place, we're assuming that that's a tangent. That's just one point. The other way is if the segment terminates at a circle, we have to really know that that forms a right angle with the radius. And if it does, then that's a tangent. So in these two cases, we have tangents. And so I can use my formula, va vive. And now I'm going to plug stuff in. So this would be X. Oh, wait, I'm going to label it. There's V, there's A, there's E, and there's I. However you want to label the EI is fine. But VA times VA is X times X. And VI is all the way across. That's 12. A plus 4 is 12, and VE is 4. So there it is, and we have X times X is X squared, and 12 times 4 is 48. So now we have to take the square root of both sides, and X is equal to the square root of 48. Now there's two ways we could do this. We can get a calculator out, but I'm going to go ahead and just simplify the square root of 48. Remember, I can do this by factoring out perfect squares, and 4 is a perfect square times 12. So that's a perfect square. And I'm looking for these perfect squares. So there's another 4 in there. And 4 times 3. So now I'm going to just separate this out into the square root of 4 times the square root of 4 times the square root of 3. And these two are perfect squares. So that's 2 times root 3. So that's 4 root 3. So I have X equals 4 root 3 as an exact answer. For F, I'm going to go ahead and do this now. The reason we have this segment in there is just showing that that's a tangent to the circle because we have a right angle. I don't know anything about that, and I don't want to find that. I've got a vertex here where the two lines intersect, and that's where it intercepts the circle at the tangent point. And this would be E and I out here. So in my formula, I've got VA, which is 10, times VA, which is another 10. And I have VE, which is X, times VI, which is X plus 3X. And I'm just going to put that down. X plus 3X for that one. A little bit of work we have to do. X plus 3X. That's 1X plus 3X is 4X. So I have 4X there. Actually, I switched those, but it doesn't matter. This one's VI. That one's VE. So, but that doesn't matter because we're multiplying them. All right, so on the left-hand side, we have 100. On the right-hand side, we have 4X times another X, which is 4X squared. And we're going to solve that. Divide by 4. Square root. So we have X equals 5 on this one. Oh, looking at that, that would leave this one to be 5. VE is 5. And then EI would be 3 times 5 would be 15. There are a couple more. Okay, let's look at the next couple of examples. This first one, G, pretty straightforward, I think. Go ahead and set this one up.